Hi, if you have been following me very carefully, you will see that on this channel I'm working on a series of functions. We are finding the Laplace transform of all these functions, and we did for a function e to the power at, an exponential function, and then we did for hyperbolic functions, all in this same playlist. For hyperbolic functions, we worked on sin at and cos at. So now we are applying that knowledge here. And I would want you to look at these videos. It's very important if you really want to understand these things in class. So locate my videos for exponential function Laplace transform of f of t equal to e to the power at. So you can locate the videos for that one, and then locate for cos at or sin 80, any one of them that you want. So we will apply cos 80 and then e to the power 80 in this one. My name is Daniel, and let's start what we have today. So in this one, like I said earlier, the Laplace transform of an exponential function e to the power at, which we've already discussed on this page, is equal to 1 over s minus a. The result of this, when you find the Laplace transform of this was the result we had. You can look at that video. And then the Laplace transform of the hyperbolic function cos at, we've got the result s over s square minus a square. So this is for cos 80. There is another one for sin 80. You can locate that one too. Now look at this two very carefully. After finding the Laplace transform of e to the power 80, where a is a scalar and a positive one, then the result is negative. If this side is negative, this place will be addition, which is plus. But when we come here for cos 80 and sin 80, which is hyperbolic function, the result for cos 80 is this, and the result for sin 80 is a over s square minus a square. So you can look at that one. It represents the imaginary part of the function. Now I am about to substitute these ones here. So let's see what we have. Now don't forget that a here is a scalar and it is representing 2, and then a here is also a scalar representing the number 4. So we can apply that knowledge. So I'll take it one by one. So first we find the Laplace transform of e to the power 2t to the power 2t. Now I've already done an example for this function. You can also locate that one. So this is equal to 1 over s minus 2. Okay, then we move on to the Laplace transform of cos4t. So Laplace transform of cos4t, we realize that the solution from here, we can substitute that is equal to s over s square minus 4 square. This is giving you s over s square minus 16. Now we can substitute the result into the question. We have 4 times this result, 3 times this result. So the Laplace transform of f of t given to us will be equal to 4 multiplying the result of this one, which is 1 over s minus 2, plus 3 multiplying the result of this one, which is s over s square minus 16. So now this is very simple for you to solve. Now this is 4 times 1. Don't forget this is a whole number. It's multiplying the numerator. This is over 1. So we have 4 over s minus 2 plus this is 3s over s square minus 16. So your next step is to just take LCM for both functions. I'll do that for you. So once you take the LCM here, we have this function times this function as our LCM, then s square minus 16. Now watch very carefully. S minus 2 will cancel this one. If I take this function and I divide by s minus 2, they will cancel out. We will be left with s square minus 16. For the sake of some of us that have problems in maths, I remember I taught this in class some time ago. People did not get something like this. So if I have s minus 2, then s square minus 16, this is basic maths. Since we are finding the LCM, starting from here, I will just divide the whole result by s minus 2. Okay, now this will cancel this, we are left with this one. So now we pick this result, we use it to multiply 4, which is the numerator. So we have 4 multiplying s squared minus 16, then plus, we put it here. Then we do the same thing for this function. It will cancel this one out, we are left with this side. We use it to multiply. So we have 3s times s minus 2. Okay, so that is it. Now from here, you expand an open bracket. So this will be equal to 4 times this. We have 4s squared. Then 4 times 16 is giving us minus 64 plus this time this we have 3s squared. This time this we have minus 6s. So you divide this result by this. You can choose to expand the denominator. Okay, so let me not waste time. S minus 2 s squared minus 16. So we rearrange this and group like terms, add those ones that are the same. This and this are common, so we can add them. So adding is giving us 7s squared, 4 plus 3. Then we arrange it in descending order. S squared, we move on to this side. This is giving us 6s minus 64. You divide this by s minus 2 s squared minus 16. You can choose to expand the denominator. Okay, so the Laplace transform of the function f of t, I don't want to write the whole function, is giving us this. So we end it here. F of t was equal to 4e2t plus 3Cosh4t. So thank you for joining me here. My name is Dan. Please support this work. Share these videos with your friends who need it. And I will see you in the next one.